Here's our two basic rules with trig functions. Okay, the main rules that we're going to deal with are sine and cosine. If our function is the sine of x, then the derivative is cosine of x. If our function is cosine of x, then the derivative is negative sine of x. Okay? So the derivative of sine is cosine. The derivative of cosine is negative sine. Right. Now, as with our exponential functions and our logarithmic functions, the challenge is not so much in remembering the rules as it is in using them in conjunction with the chain rule or the product rule or quotient rule or things like that. Okay? Now, before we get into actually using this, I want to show you something that Mrs. Barbag actually came up with that's really, really helpful in helping you remember these, okay? It's SC, negative S, negative C, okay?
Oh, we do it cosine, because cosine, sine, negatives in the middle. It's easier to remember.
Oh, you put the S on the bottom?
But like, because if you say like cosine, then it's. Because look, cosine, sine, cosine,
Oh,
negatives.
okay. Okay. Yeah. Either way, you'll get the cycle here.
Yeah.
I don't understand the things in the right column. Why are they different from the things in the left?
What, this versus this?
Yeah.
They're not different. They're just the same thing, just slightly different notation. Here we're defining y as a function. So dy dx is this. Here we're just saying the derivative with respect to x of sine of x is cosine. Okay? Just slightly different notation. But here's the deal. If you remember this, as you go down here, you're finding derivatives. Okay? The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. The derivative of negative cosine is sine. Okay? It's like a big circle. Okay? Later on, we're going to look at integrals, and the integrals actually work backwards. Okay? So the integral of sine is negative cosine. The integral of negative cosine is negative sine. Integral of negative sine is cosine. Integral of cosine is sine. All right, so that works backwards there. That's just an easy way of remembering it. So hopefully that's helpful. Well, let's look at actually using these, okay? Because that's really where the challenge lies. All right, let's start with one where we have the sine of x squared minus 3x plus 5, okay? What rule are we going to use here? Chain rule, okay? We've got to use the chain rule, okay? In the chain rule, we have g of u, and we have u, okay? U is that inner function, the x squared minus 3x plus 5. G of u is the outer function. In this case, it's the sine of that inner function u. So if I'm finding dy dx, I have to do g prime of u times u prime. Okay, the derivative of the outer times the derivative of the inner function. Okay? The key here is when you take the derivative of the outer function, okay, what is g prime? What's the derivative of sine? Cosine. So when I do the cosine, notice it's still u inside of it. Okay? So it's still the cosine of x squared minus 3x plus 5. Okay, u is still there. Then we're going to multiply by
2x.
yeah, 2x minus 3. By the way, be careful with parentheses. Okay, I'm going to give you those quizzes back tomorrow. We're going to use that to help us a little bit. Some people were losing parentheses, and that was throwing off answers. Okay, so be careful with those.
Did y'all, as a class, what was the class average? Well, or?
I don't know the class average. They is so. Some of those were tough. Some of you missed some like easy things that would have made life easier. But we'll go over that tomorrow. Okay. Now, here we have y equals sine cosine.
Is this a separate problem?
Yep. So what are we going to use in this case?
Product rule.
Product rule. Good. Product rule. Okay. So sine is u, cosine is v, right? So u prime
So cosine.
is cosine of x. And these are nice. They only have x's, so we don't have to use chain rule. All right? But what's v prime?
Negative sign.
Negative sine. Okay? So in this case, dy dx is u prime v plus uv prime. Okay? The product rule is plus. Okay? Some people were using minuses on the quiz. All right. So here, u prime is cosine times another cosine, because that's v, plus u, which was sine, times, negative sine, the v prime.
But can you use the rules?
What rules?
Like, I really don't remember.
You thinking about trig rules?
Yeah, because like that's one.
It's almost one. It's not, it's almost that rule.
But you know what I mean? Like if they came out to those rules, they still apply.
Yes, they
Because
still
you already
apply.
taken the derivative, so it
They
doesn't
still
matter.
apply, yes. And actually, this one, I know you're thinking sine squared plus cosine squared is 1.
Yeah, so
Okay.
what's the difference?
This one, well, this
Oh, it has
is
to be negative, it has to be
minus. So actually, this is one of our identities, and this is where you maybe using your formula booklet would be helpful. They might say, show that dy dx is cosine of 2x. And you get here and you're stuck. Well, then you look in your formula booklet and you remind yourself that, oh, cosine squared minus sine squared, that's our double angle formula. That equals cosine of 2x. Okay? Now, I know it's been a while since we did that one, but that's where it's nice you have the formula booklet, because that was over a year ago, or about a year ago. Okay?
So if like either one of those answers is correct.
Yeah, if you were just doing this to find the derivative, I would take this cosine squared minus sine squared. That'd be fine. Okay? But don't be surprised if maybe you got one that said, hey, show that it equals this. So you're having to do the derivative and then recognize the trig identity. Okay?
If you just like open the random piece of paper and you saw y equals sine of x times cosine of x, how do you know to take the derivative? Will there be direction?
Well, yeah, there's going to be directions. I mean,
There's no direction. Right?
So- you'd have some kind of a problem where you were trying to find a rate of change, okay, or the slope of a tangent line. You know, so hey, I've got to do derivatives there. All right, let's try this one. Okay, if y equals sine divided by cosine, we're going to have to use the quotient rule. Okay, quotient rule, which happens to be u prime v minus u v prime all over v squared. Okay? Other formula. Okay. So, product rule is plus. When you're dividing, you're going to find a difference. Okay? All right? Product rule is plus. Dividing gives you a difference. So we subtract. All right? Now, we need to find out what u prime and v prime are, because this is u, the numerator always, and v is always the denominator. So what's u prime?
Cosine.
Cosine. And what is v prime? Negative sine. Okay? So, u prime times v is cosine squared minus u times v prime. Yeah, is a minus sine squared, so that's going to make it a plus sine squared x over cosine squared. Good. Now, here is what you were talking about. What's cosine squared plus sine squared? 1. And what is 1 over cosine? It's one of those secant, okay? So what's 1 over cosine squared? Secant squared. All right. So guess what we just found, okay?
We just did a lot of stuff.
So here's the thing.
We used the derivative to find the identity.
We use the derivative, and we use some identities, but check this out. What is sine divided by cosine? Tangent. So guess what we just did? We just derived the fact that the derivative of tangent exactly is secant squared. Okay? That's another rule. Okay, that if you take calculus in college, you'll have to memorize. All right? Or in AP, they have to memorize.
Great.
Okay?
Another thing to look forward to.
So that's another rule. And the fact of the matter is, we can do that with all of these. Okay? Here's cosecant. What's the derivative of cosecant? All right? Well, cosecant is sine to the negative 1, right? So the derivative, we're going to use the chain rule, right? Negative 1 times sine to the negative 2 power times chain rule times cosine. Okay? So this is a negative. This is sine to the negative 2 power. I'm going to do a little bit of working with this. It's a negative 1. I'm going to make it a 1 over sine times, I'm going to take one of these two sines here and put it under the cosine. Okay, once this catches up. Are you going to catch up? There it is. Okay.
1 times sine x to the negative.
Chain rule. The outer function is something to the negative 1 power.
Is that minus 2?
Yep, now it's the negative 2 power. So here are my sine squared. I just switched it up because now I have a negative. What's 1 over sine? Cosecant times cotangent. So the derivative of cosecant is a negative cosecant times cotangent. Okay? The derivative of secant, we're going to run out of time, so I'll give these to you here. The derivative of secant is actually very
Is
similar.
that minus or times?
It's times. What do you think, since I'm telling you it's pretty similar, what do you think it might be? Secant times
Negative
times tangent. Okay? Secant times tangent. Okay? And then cotangent, we could do just like the tangent. All right, and it's actually kind of similar to the tangent one. What do you think it is? Tangent was secant squared. So what do you think cotangent is? Not cosine squared. Cosecant squared. Okay? Cosecant, and it's actually negative cosecant squared. All right, so there's a couple of things that actually make this kind of easy to remember. First of all the trig functions that start with c have derivatives that are negative. Cosines, negative sine. Cosecants, negative cosecant cotangent. Negative, that's wrong. Cotangent is negative cosecant squared. Secant starts with an S, so it's positive. Okay? Yes, you can't start secant with a C. Alright. Alright, so that's just one nice way to remember the negatives. The ones that start with C have negative derivatives. Okay?
The letter C.
Secant and cosecant, they're part of their own derivative. And then if you remember the Pythagorean identities, secant went with tangent and cosecant went with cotangent. That'll help you remember which goes with them. Okay? So a couple of things there to help you remember there. Okay? So, just a summary, let's run through all of these again. The derivative of sine is, come on guys, derivative of sine is cosine. The derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cosecant, negative cosecant times cotangent. And secant times tangent. And cotangent is negative cosecant squared. Okay? All right. We're going to practice some of this. Listen, if you're behind, use tonight to help you catch up. There's no independent practice, a little behind, okay? So use this time to catch up and come ready to practice, and we're going to go over the quiz and stuff tomorrow, okay? All right. Have a great day.